Welcome to the Deep Dive. Today we're doing a daily news roundup, specifically from the world of AI research. I'm joined by an expert to help us break down some of those interesting papers published just today on rx4v.org.
Yeah, we've got over 40 articles to get through, covering everything from the limits of prediction to the use of quantum computing in speech emotion recognition.
Wow, that's a lot to cover.
It is, but I think we can extract some real gems for you today.
Okay, so before we get lost in the weeds of individual papers, are there any big picture trends or themes emerging from this batch of research? Anything that really jumps out at you?
Absolutely. One thing that's really striking is the sheer volume of research focused on handling missing data. It's clearly a major challenge across many different AI applications, and we're seeing a lot of creative new approaches to tackling this problem.
Interesting. Can you give us an example? Why is missing data such a big deal, and what are some of these innovative approaches?
Sure, take DeepIFSO, for instance. This paper proposes a deep learning model with attention mechanisms to impute missing values. Think of it like teaching the AI to focus on specific features and relationships within the data to intelligently fill in the gaps.
Okay.
This could have huge implications for fields like medical diagnosis, where incomplete patient data can lead to inaccurate or delayed treatment.
So it's not just about filling in the blanks randomly, it's about using AI to make educated guesses based on the existing data. That makes sense.
Yeah.
What other approaches are researchers exploring?
Another interesting paper is PAIN, which stands for Probabilistic Autoencoder for Imputation with Noise. It uses a combination of statistical methods, random forests, and autoencoders to impute missing values in a way that balances accuracy with uncertainty.
Yeah.
The beauty of this approach is that it doesn't just spit out a single best guess. It provides a range of possible values with associated probabilities.
So instead of just giving you a single answer, it's giving you a sense of how confident the AI is in its prediction. That seems like a much more robust approach, especially when dealing with sensitive applications like medical diagnosis or financial modeling.
Exactly, and this focus on quantifying uncertainty is something we're seeing more and more in AI research. It's no longer enough for AI to just give you an answer.
Right.
We need to know how reliable that answer is and how it was arrived at.
That makes sense. Transparency and explainability are becoming increasingly important as AI systems play a larger role in our lives. Now, shifting gears a bit, another area that caught my eye is the research on multimodal large language models, or MLLMs. What's so exciting about this field, and what are some of the key developments we're seeing?
MLLMs are all about integrating different types of data text, images, audio, to create AI systems that are more versatile and human-like. They're capable of understanding and generating content across multiple modalities, which opens up a whole new world of possibilities.
Can you give us a concrete example? What kind of real-world applications can we expect to see from MLLMs?
Imagine a mobile assistant that can not only understand your voice commands, but also interpret the visual context of your surroundings. Or an AI-powered educational tool that can personalize lessons based on a student's facial expressions and body language.
That's incredible. It sounds like MLMs could revolutionize the way we interact with technology.
Yeah.
What are some of the specific papers that showcase the potential of this field?
One standout paper is Mobile Agent E, which proposes a self-evolving mobile assistant that learns from experience. It's basically a digital butler for your phone that gets smarter over time by observing your interactions and adapting to your preferences.
That sounds like something straight out of science fiction. Are we really that close to having AI assistants that can learn and evolve on their own?
Well, it's still early days, but the research is moving incredibly fast. Another fascinating paper in this space is focused on the Chinese insurance industry. They've developed a benchmark called InScaBench, specifically for testing how well LLMs can answer questions in this complex field. It highlights how AI is becoming increasingly specialized, tailored to specific industries and tasks.
So instead of trying to create one-size-fits-all AI systems, researchers are focusing on building models that are experts in specific domains. That seems like a much more practical and effective approach.
It certainly does, and it speaks to the growing maturity of the AI field as a whole. We're moving beyond the hype and starting to see real-world applications that are making a tangible impact.
That's encouraging to hear. Now, I have to ask about a paper that really caught my eye, The Unknowable Limits to Prediction. It delves into the fundamental question of whether everything can be predicted or if there's inherent randomness in the universe. That seems like a pretty philosophical question for an AI research paper.
It is. But it's also a crucial question to consider as we develop increasingly powerful AI systems. If we're going to rely on AI to make decisions that affect our lives, we need to understand the limits of its predictive abilities. This paper doesn't necessarily provide any definitive answers, but it raises some important questions about the nature of prediction and causality.
It's a good reminder that even with all the advancements in AI, there are still fundamental mysteries about the world that we may never fully understand. What are your thoughts? Is there anything we can truly predict with 100% certainty?
It's a question that philosophers have been grappling with for centuries. What this paper does is bring that question into the realm of AI research. It reminds us that while AI can be incredibly powerful at finding patterns and making predictions, there will always be limits to what it can know.
Well, that's a thought-provoking start to our deep dive. We've covered a lot of ground already, from the challenges of missing data to the potential of MLLMs and the philosophical questions surrounding the limits of prediction. And we're just getting started. Let's take a quick break and then come back to explore some more of the fascinating research that's been published today.
Sounds good to me. I'm eager to see what other insights we can uncover. As we dive back into these research papers, one thing that really stands out is the incredible breadth of applications for AI. It's truly touching every aspect of our lives in some way.
It's amazing to see how AI is being used to tackle such a diverse range of challenges, from predicting the spread of diseases to translating ancient texts. It seems like there's no limit to its potential.
We have one paper here focused on predicting lung metastasis from hepatocellular carcinoma.
Oh, wow.
They're using machine learning to identify patients who are at high risk, which could lead to earlier intervention and potentially save lives. It's a powerful example of how AI is being used to improve healthcare outcomes.
That's incredibly impactful work.
Yeah.
But then on the other end of the spectrum, we have a paper using AI to analyze the translation of biblical proverbs.
Right.
It's fascinating to see how these models are becoming adept at understanding not just language, but also the cultural context in which it's used.
The paper Proverbs Run in Pairs really highlights how AI can be applied to nuanced and culturally significant tasks.
Yeah.
It makes you wonder what other seemingly untranslatable aspects of human culture AI might be able to unlock.
It's mind-boggling to think about the possibilities. Now let's talk about the practical side of things. Training and running these large language models can be incredibly expensive and resource-intensive. Are there any efforts to make them more efficient and accessible?
Absolutely. There's a paper here called Glinhawk that proposes a two-tiered architecture for high-throughput LLM inference.
Yeah.
This could potentially make these powerful models more affordable and accessible to a wider range of researchers and developers.
That's a game changer.
Yeah.
If we can make this technology more accessible, it could open up so many new possibilities for innovation and discovery.
And it's not just about making existing models more efficient. We're also seeing new techniques to enhance their performance. For example, the paper Advancing Language Model Reasoning explores how reinforcement learning can be used to improve LLM's ability to reason and solve complex problems.
So it's like they're teaching these models to think more strategically and learn from their mistakes.
Yeah.
What kind of results are they seeing with this approach?
They've shown significant improvements on challenging math reasoning benchmarks, which is quite impressive.
Wow.
It suggests that we can push the boundaries of what these models are capable of with the right training techniques.
It's remarkable how quickly this field is advancing. What was considered cutting edge just a few months ago is already being surpassed. It's a constant evolution.
That's the beauty of AI research. There's always something new to discover and always room for improvement. Speaking of which, we also have some interesting work on the topic of uncertainty in AI.
That's a crucial aspect that we touched on earlier. Can you tell us more about how researchers are addressing this challenge?
The paper Selective Uncertainty Propagation in Offline RL proposes a new method for quantifying uncertainty in reinforcement learning models. This could lead to more reliable and robust AI systems, especially in safety-critical applications.
It makes sense. If we're going to trust AI to make decisions that affect our lives, we need to understand how confident it is in its predictions. And if it's uncertain, we need to know why.
That brings us to the concept of explainability, which is another key aspect of trustworthy AI. There's a fascinating paper here titled Closed-Form Interpretation of Neural Network Latent Spaces that offers a new approach to understanding what's happening inside the black box of a neural network.
So it's like giving us a peek behind the curtain to see how the AI is making its decisions. That can be incredibly valuable in building trust and ensuring that these systems are being used ethically and responsibly.
Exactly. The paper uses a technique called symbolic gradients to extract human-readable interpretations of what's going on in the neural network. It's a promising step towards making AI more transparent and accountable.
That's really encouraging to hear. It seems like there's a growing awareness of the need for ethical and transparent AI development. Are there any other papers that highlight this trend?
We have one here that provides a comprehensive overview of the challenges and opportunities in making vision models more explainable. It's called Explainability for Vision Foundation Models, and it really emphasizes the importance of designing AI systems that are not only accurate, but also understandable and trustworthy.
So it's not enough for AI to just work well. It needs to be transparent, accountable, and aligned with our values. That's a powerful message.
It is, and it's something that researchers are taking increasingly seriously as AI becomes more integrated into our lives.
Now, as we delve deeper into this research landscape,
Mhm.
are there any other emerging themes or trends that you're noticing?
One that's particularly intriguing is the idea of moving beyond specialized AI systems towards more general purpose models.
Yeah.
Models that can adapt to new tasks and domains without needing to be completely retrained from scratch. This is often referred to as transfer learning.
That sounds incredibly powerful. It's like having a multi-talented individual who can pick up any instrument and play it like a pro. They have this core set of skills that they can apply to different musical styles and genres.
That's a great analogy. And in the AI world, this means we could potentially train systems that are more versatile and adaptable, able to learn new things without needing to start from square one every time.
Are there any specific papers that demonstrate this concept of transfer learning in action?
We have one here called Optimizing Pre-training Data Mixtures that explores how to create models that can be pre-trained on a massive data set and then fine-tuned for specific tasks with minimal additional data.
Interesting.
This could significantly reduce the time and resources required to train AI models for new applications.
It's a huge step forward.
Yeah.
Are there any real-world examples of how this is being used?
There's a fascinating paper here that tackles the challenge of translating legal documents, specifically case law in Hong Kong. They're using a combination of machine translation and human expertise to tackle this incredibly complex and nuanced task.
So they're essentially combining the strengths of AI and human intelligence to achieve something that would be incredibly difficult or even impossible to do manually.
Exactly, and it highlights how AI can augment human capabilities, helping us tackle challenges that would be incredibly time-consuming or beyond our capacity to handle alone.
It's like having a superpowered legal assistant who can sift through mountains of documents and extract the key information, freeing up human experts to focus on the more complex aspects of legal interpretation.
That's a great way to put it. And this collaboration between AI and human expertise is a recurring theme throughout many of these papers.
Yeah.
It suggests that the future of AI isn't about replacing humans, but about working alongside them to achieve greater things.
It's a much more optimistic and collaborative vision of the future than some of the dystopian scenarios that we often hear about.
Are there any other examples of this human AI collaboration in the research you've been looking at?
We have one here focused on collaborative imputation of urban time series.
They're using meta-learning techniques to enable cities to share data and improve their ability to impute missing values in urban time series data. It's essentially a global network of cities working together to fill in the gaps in their data, which could lead to better urban planning and decision-making.
That's a fantastic example of how AI can facilitate collaboration and knowledge sharing on a global scale. It really highlights the potential for AI to address some of the most pressing challenges facing humanity.
And this interconnectedness is also reflected in the paper on fine-grained spatiotemporal event prediction. They're using a novel graph-based approach to model the spatial dependencies of events, which could have applications in everything from traffic prediction to crime forecasting.
It's incredible how AI is helping us understand and predict complex systems, whether it's the human body, language, or even entire cities. As we wrap up this second part of our deep dive, I'm struck by the sheer ingenuity and creativity on display in these papers. It's testament to the incredible pace of innovation in the field of AI.
I completely agree. It's an exciting time to be following this field, and I can't wait to see what breakthroughs emerge next. Shall we move on to the final batch of papers for today?
Absolutely. Let's see what other AI marvels await us. As we embark on this final leg of our AI research expedition, I'm curious to see what other gems we can unearth from this treasure trove of papers.
There are certainly some intriguing findings in this last batch. One that caught my eye involves enhancing SAR object detection. SAR stands for synthetic aperture radar, a technology used for a variety of applications, from monitoring crops to tracking ships at sea. However, it generates some pretty complex images.
I can imagine. What's the novel approach being proposed in this paper?
The researchers are leveraging self-supervised learning, which is a fascinating area of AI research. Instead of relying on massive amounts of labeled data, they're training the AI to understand the inherent structure of SAR images by essentially playing a game of hide and seek with the data.
So they're covering up parts of the image and challenging the AI to fill in the missing pieces. That sounds like a clever way to force the AI to learn the underlying patterns and features.
Exactly. It's like teaching the AI to see the world through the eyes of a radar by encouraging it to make sense of incomplete information. This approach could lead to more robust and reliable object detection systems for SAR imagery.
That's really impressive. It highlights the importance of developing AI systems that can work with different types of data, not just the neatly labeled data sets we often see in research. Speaking of working with different types of data, there's another paper here on future-guided learning that caught my attention.
Oh, yes. This one proposes a new approach to time series forecasting, inspired by the way our brains predict future events. It's a fascinating concept.
It sounds like they're giving the AI a glimpse into the future to help it make better predictions about the present. Is that how it works?
In a way, yes. They're training the AI to use information from the future to improve its predictions about the past and present. It's a clever way to address the challenges of long-term dependencies and data drift in time series forecasting.
This brings us back to the theme of uncertainty, doesn't it? The better we can predict the future, the less uncertain we feel. But as we discussed earlier, some things may always remain inherently unpredictable.
That's right. Even with the most sophisticated AI systems, there will always be limits to what we can know and predict. This research reminds us that uncertainty is an inherent part of life, and that we need to develop AI systems that can gracefully handle the unexpected.
It's a humbling reminder that even with all our technological advancements, we're still subject to the whims of fate and the complexities of the universe. Now, shifting gears a bit, there's a paper here on analyzing nonverbal cues in social interactions that I found particularly intriguing.
The one on learning nonverbal cues in multi-party social interactions for robotic facilitators. It's a fascinating area of research with implications for human-robot interaction.
Exactly. They're using a technique called implicit behavior cloning to train robots to understand and generate nonverbal cues, like gaze behavior, which could make interactions with robots feel more natural and engaging.
It's like teaching robots to read between the lines of human communication, to pick up on those subtle cues that convey so much meaning beyond words. This could be a game changer for fields like healthcare and education, where robots are increasingly being used to interact with people.
It's exciting to think about the possibilities. Imagine a robot tutor that can sense when a student is confused or frustrated based on their facial expressions and body language.
Right.
It could then adjust its teaching style accordingly, providing a more personalized and effective learning experience.
That's a great example. And as this research progresses, we can expect to see robots becoming more socially intelligent, capable of navigating the nuances of human interaction with greater ease.
Now, before we wrap up, there's one more paper I'd like to touch on. It's a comprehensive review of how deep learning is being used to analyze multimodal data for medical diagnosis, with a particular focus on COVID-19 detection.
Ah, yes. Multimodal marvels of deep learning in medical diagnosis. This paper highlights the incredible potential of AI to revolutionize healthcare by combining insights from different data sources such as images, text, and even speech.
It's inspiring to see how AI is already making a real difference in diagnosing and treating diseases more effectively. And as we gather more data and develop even more sophisticated models, the possibilities seem endless.
I completely agree. We're witnessing the dawn of a new era in healthcare driven by the power of AI to analyze complex data and uncover hidden patterns that can lead to earlier diagnosis, more personalized treatments, and ultimately better patient outcomes.
Well, I think we've reached the end of our deep dive today. We've explored a wide range of research from the theoretical foundations of AI to its real-world applications in healthcare finance and even the arts. It's been an incredible journey, and I want to thank you for guiding us through this fascinating landscape of AI research.
It's been my pleasure. I'm always excited to share these insights, and I hope our listeners have gained a deeper appreciation for the incredible work being done in this field.
And to our listeners, we encourage you to stay curious, stay informed, and stay engaged in the conversation about the future of AI. There's so much to explore, and we'll be back soon with another deep dive into this exciting world. Until then, thanks for joining us on the Deep Dive.